Hello students, my name is Emma Reed. I'm an 8th grade math teacher, and today we are starting a new unit called the Pythagorean Theorem and Irrational Numbers, Unit 8. And on our first day, our goal is to answer the question, how can we find the area of a tilted square on a grid? And the title of this lesson is the area of squares and their side lengths. So as we work through this lesson, come back to that question, how can we find the area of a tilted square on a grid? Come ahead with me to slide A for our introduction/launch. So your warm-up or your launch for the day is to examine the shapes below, shape A and shape B, and you're going to decide which shaded area is larger and explain your reasoning. So pause, think about that question, and answer in the blue square. Once you've taken the time you need to answer your warm-up question, move on with me to slide B, where we're going to start our Explore section. So we have a similar situation, and our goal is to determine what is the area of the shaded region, and how do you know? So you want to especially emphasize that question, how do you know? How are you visualizing to figure out the area? Be as descriptive as possible, and pause to think for slide B. Once you've had enough time to come up with your reasoning and answer slide B, come ahead with me to slide C, and we're answering the same question. What is the area of the shaded region, and how do you know? Again, really emphasize the how do you know part of this. How did you figure out your answer? Why are you confident that it's correct? Pause and think. Now move ahead with me to slide D. What is the area of this shaded region, and how do you know? Once you've given your answer for slide D, you can come with me to slide E, where we're going to summarize. So to prepare for your summary, record your response to the focus question. How can we find the area of a tilted square on a grid? And use this space to record notes on the right from your lesson that you want to remember for the future. Now that you have finished this lesson, I'm going to give you an extension for if you finished early, or if you felt like this lesson made a lot of sense to you and you're ready for the next step, or if you just think that it's interesting to play around with area. Move ahead with me. We're going to go to a different website, and I'll give you the website that you can go to so you can do this task along with me. So we're going to switch to that new website now. Here we are at mathagon.org, and you're going to go to this website up in the left-hand corner. I'll highlight it for you. It just says mathagon.org/task/Curry's paradox. So we're going to try, I'm going to zoom in. Okay, so we're going to try to arrange the 4 pieces below so they fit perfectly inside the triangle. So you're with me hopefully on the right website, and you can move these shapes around and see if you can fit them perfectly inside the triangle. And if you need a hint, pause and play with it. And if you decide you need a hint, you can scroll down. And there's the hint if you need it. Once you have all the shapes arranged in the triangle, we're going to scroll down for the next step. So now we're going to rearrange the pieces into the same triangle using the new outline shown in the second triangle. So do that. And when you're ready, you can move ahead and scroll down again. So what is happening here? The triangle didn't get bigger, and the pieces stayed the same size, and yet we have an empty square in the triangle. So pause and think about how could that happen? And once you've thought about what you think is happening here, you can scroll down and see that this exploration is called Curry's paradox. A paradox is a contradictory situation. So here we have the same four shapes that seem to have different area based on how we arrange them. That doesn't seem to fit with our understanding of area. Can you explain what's happening here? Mathematician Haskell Curry created this paradoxical situation. All right, so now we can make sense of these by finding the area of the triangles and the shapes. And you can use the grid to help you come up with the area. And you can enter it on your own screen. And once you had enough time to find the area, move the shapes around, you can scroll down again on your own screen. And you can see the So the issue is the triangle has an area of 32.5, while the four pieces together have an area of 32. So that must mean when arranged in this manner, the four pieces don't quite fill up the triangle. And when arranged like this, the four pieces plus the extra square have an area of 33. So they must be extending beyond the triangle slightly. The blue triangle and the red triangle do not make a straight line. To see this, you can drag the blue triangle on top of the red triangle, and you'll see that the longest sides, the hypotenuse, don't line up exactly. You will probably need to zoom in. Here's a close-up. So the blue triangle goes up 2 units for every 5 units over, and you can think back to what you learned about slope, while the red triangle goes up 3 units for every 8 units over, and their slopes therefore do not equal one another. So the steepness of the black triangle is in between the steepness of the blue and the red triangle, and you can see an exaggerated version of the situation. And then there's an extension on our extension where you can try making up a paradox of your own. And again, all of these were on mathagon.org/tasks/Curry paradox. I'll put the website again. Thank you for joining me and for participating in this extension, and have a beautiful day.